Did you know jet engine cables can withstand 700 degrees Celsius or 1,292 degrees Fahrenheit? How do fighter jets and rockets endure such extreme heat? The secret lies in advanced aerospace alloys like Inconel 718. These innovations are revolutionizing cable assemblies, driving high-performance connectivity across industries. Material science is at the core of this transformation. Conductive alloys, composite cores, and advanced polymers are pushing the boundaries of cable capabilities. From terabit data transmission in hyperscale data centers to megawatt power transfer in renewable energy grids, the materials chosen are crucial to a cable's performance. Composite-core technologies are a radical departure from traditional conductor designs. For instance, aluminum conductor composite-core cables achieve a 60% weight reduction compared to steel-reinforced cables while doubling current carrying capacity. These advancements are redefining strength-to-weight ratios in cable assemblies. In environments demanding extreme durability, nickel-based superalloys like Inconel 718 are gaining traction. It's ideal for aerospace engine harnesses, offering superior oxidation resistance crucial for cables exposed to jet exhaust or rocket plumes. The materials revolution in cable assemblies is redefining power and data transmission. From carbon nanotube conductors to self-healing insulators, these advancements solve engineering challenges and promote sustainability. To keep up with the latest in technology, like and subscribe for more fascinating insights.